we have seen how to find the unit digit of a power. Very occasionally, when the paper is very tough in quant, you could have a question of asking you to find the last two digits. And by the last two digits, we mean the rightmost two digits, right? The units and the tens digit. This is just a colloquial usage, the last two digits, right? This question is also very similar to find the remainder when a raised to b is divided by 100. If you divide any number by 100, the last two digits is going to be the leftover remainder. So remainder when divided by 100 is as good as the last two digits, right? I'll not waste time explaining that out over here. So let's handle our task at hand, right? And to answer this, we need to be aware of the binomial expansion. And so let me just briefly start with the binomial expansion. Binomial expansion may be new to a few students, so I'll just be a little slow. Binomial, bi is for 2. So I would have two terms, a plus b raised to n. And this is what I'll be expanding. It is a very easy format, right? So even if you're totally unaware of it, you can learn it like this, right? Just be very appreciative of the pattern, right? You have two terms, a and b. So let's start with one of the term a raised to n. And in terms are separated by plus sign as such, right? The powers of a will keep reducing. So the next one is going to be a raised to n minus 1, and the yet next one is a raised to n minus 2, and it will keep reducing till the end it is going to reach as a raised to 0. The one just before the end is going to be a raised to 1, the one before it is a raised to 2. So n minus 1, n minus 2, n minus 3 and so on till 2, 1, 0. Right? So from 0 to n, there are going to be n plus 1 terms, right? That itself becomes one of the property of binomial. What about b? There's going to be a b with each of these terms, and the powers of b are the reverse of this. I repeat again, reverse. So we will start with a b raised to 0, and there's a product here. The next one will be a b raised to 1, and the next one is going to be a b raised to 2. So powers of b are increasing from 0 to n. A is decreasing from n to 0. b raised to 0, b raised to 1, b raised to 2 and so on. What will be here? Hang on for a minute. Let's start from the last. The last is b raised to n. So the one before that is b raised to n minus 1. The one before that is b raised to n minus 2. It has increased till b raised to n. Right? And so both ends should look very symmetrical. A raised to n, b raised to 0. A raised to 0, b raised to n. The only difference is in the interchanging of a and b. One power is increasing, one power is decreasing. Let's say 1 rupees is added to one pocket and 1 rupees is removed from one pocket. What happens is the amount that you have in total is a constant. So if I add these two, n plus 0 is an n. If I add these two powers, it is again an n. If I add these two powers, it's again an n. So you could have seen if this is a 2, this has to be n minus 2. If this is 1, this has to be n minus 1. Or the general term, if the power of a is r, the power of b has to be n minus r, because together they have to add up to r. That's called the general term. And to finish it off, there's a coefficient to each of these terms, right? And while this all is very familiar, or most students appreciate this, the moment the coefficient comes, they blank out. Why? Because the coefficient is the term in NCR. We are not going to use it too much, so chill out for the moment, right? We just write it as C0, coefficient 1, coefficient 2. Similarly here, by the time you reach here, it's coefficient n minus 1, coefficient n minus 2. Right? And what do we mean by C0, C1? It's basically NC0, NC1, NC2, NCn minus 2, NCn minus 1, NCn. Right? And here the term is going to be NC r or n minus r. For those who are okay with it, you know the both are same, right? Don't worry about it. I'm not teaching you that. This is your binomial expansion. So there are many terms in between. This is your complete binomial expansion. At least be appreciative of the format of it, and if nothing more. If you do not, are not very comfortable NCR, NC1, NC2 or NCR in general, just leave it, just remember there is such a term and this is the binomial expansion. I'd also take this opportunity to drive in one more fact. There are quite a few people who treat a minus b raised to n very differently. And a way that a beginner remembers are terms are alternately positive, negative, positive, negative. So the first is positive, this second term will become minus, third will become positive, fourth will become minus. All these are just tricks, thinking that students can't think on their own. All you have to do from year to year is just substitute the b with a minus b. So I'm not even going to write this. All I'm going to say, in the above, substitute b with a minus b. And that's it. Do not learn any new formula. So if this is a minus b raised to 0, b raised to 0 is 1, minus b raised to 0 is 1. It's going to not make any difference. If this is a minus b raised to 1, it is minus of b raised to 1. So this sign will automatically become a minus. A b square and a minus b, the whole square, makes no difference. So this is going to remain a positive. I hope you got that. So I'm really not interested in writing the whole thing down all again, right? In fact, what I'm going to use in questions is, why I did this is, in questions I'm going to use this format more. Now, those who study, just patterns will struggle to place this, will change the order over here, B minus A will struggle. It makes no difference. All I'm going to do in the above is substitute A with a minus A. That's it. And I'm not going to make any other changes, right? So, this session is not on binomial expansion. We will have a separate lecture on binomial expansion. This is, you need to know the binomial expansion to find the last two digits. Finding the last two digits in most of the cases is a very simple matter, provided you have just basic awareness of the binomial expansion. So let's again get going with the task in hand with this rudimentary understanding of binomial expansion.